So, the first part of chapter 7, the first section in chapter 7 is absolutely the easiest thing for you guys because you've done it since you were freshmen. Problem A, I'm in my notes, 7.1. Problem A says solve with substitution. Well, that's easy, right? What does y equal?
X squared. What does y equal?
Y equals x squared.
Yeah.
So I can take that and plug it in right here.
And then get a difference.
So x squared minus 9 equals 0. What do you mean what? We're in our notes, 7.1. This is the first problem, I think.
Oh, never mind.
Okay. So then, what does this tell me about x? X is either going to be 3 or negative 3. Well, what do I know about y? What's y?
X squared.
Which is
9.
9. So I have two answers. If x is 3, y is 9. What if x is negative 3? Y is 9. Now, you aren't always going to get two answers, but I want you to remember that y equals x squared is a parabola, and y equals 9 is basically this equation is a horizontal line. So how many places do they cross? 2. That's why I got 2 points of intersection. Remember, when you solve a system with substitution or elimination, or some of the new methods we're going to learn, what you're looking for is where the figures intersect. They intersect in 2 points. All right, what about B? What are we going to do here? In real life, you can solve it any way you want, but these directions say we are going to use substitution. So, sir, what do you want to do?
Y plus 3 minus y squared equals 3y.
Okay, so what sir is doing is he's taking his top equation and he's getting x by itself. So does everybody see what he's doing? You don't have to do this, but you see what he's doing? Now, this is x. So we'll plug that in here. And then our equation says 3 plus y minus y squared equals 3y. If I plug that in for x. What do I do with that? It's set equal to 0. And I want it set equal to 0 because isn't it a quadratic? And I'm either going to factor it or use the quadratic formula. So I'm going to rearrange it. I'm going to add y squared to the other side. I'm going to subtract 2y, subtract y, and subtract 3. So I added y squared, subtracted y, subtracted 3 to get it set equal to 0. This is for why didn't you just subtract 3y? Because then my y squared is negative. And I'm a math teacher and I'm 63 years old, but I just don't like to factor when my y squared is negative. I like to have a positive. It's a Lisa Ford personal problem. Do whatever you want. Just get the answer, right? All right, does that factor? So y is either negative 3 or y is 1. So I have 2 points again, but I'm not done because I still need to figure out x. Now let's see, it'd probably be easiest to put it right here, wouldn't it? To plug in y. So if I put in negative 3 for y, x turns out to be 0. And if I put in 1 for y, x turns out to be 4. Anybody have a question about that before I erase it? All right, let's try the next one. All right. What do you think, Ethan? You have an idea if we have to substitute, what might be a good way to go about that?
You could move the 3y over.
Very good. Remember, if you're substituting, you want to get x equals or y equals. So you can substitute, and it never makes any difference. But this one's easy because x is already by itself. So if I add 3y, I'm going to get 6 plus 3y. Right? Now I'm going to take this guy and plug him in here. So what happens when I do that? I get -2, 6 plus 3y, plus 6y equals 4. All right, so -12 minus. Jeff's yawning. How can you yawn in the middle of this? This is, what's going on here? So you're going to end up with -12 equals 4, which we know is not true. So tell me what's going on here. Remember, I'm trying to find the points of intersection. I'm trying to figure out where these things cross each other. What's happening? They don't intersect. These are lines, and these lines are parallel. Absolutely, we have parallel lines. All right, sir, what were you going to say?
I was gonna ask if they would cancel.
They do. Yep. They did. They sure did. All right, one more of those, and then we'll do some elimination. All right, so it looks like this one is already set up for substitution. Would you agree? So can I just say 1 minus x equals 1 plus 2x minus x squared? It's another quadratic equation, isn't it? So I don't care which way you go, I'm going this way, so my x squared is positive, so I'm adding the x squared. I'm subtracting the 2x, and I'm subtracting 1. I think that's what I end up with. Look that over, is that what you ended up with? How do I factor that? Abby?
Take out the x and then it's x equals 0.
Perfect. All you can do there is take out the GCF, just pull out the x. And then as Abby said, that means x is 0 or x is 3. So once again, we have 2 points of intersection. We write our answer as ordered pairs, and this time it's x. So x is 0 or x is 3. Let's pop right up here. If x is 0, y is 1. And if x is 3, y is -2. I promise chapter 7 is going to get a little bit harder, but not yet, because now we're going to do elimination. Who remembers how elimination works? We just did a bunch of problems with substitution. You get one letter by itself and then plug it in, right? how does elimination work?
You have to get like one of the letters.
Exactly. You do whatever you need to do so that when you add these together, add them, one of the variables drops out. If I add here, the x's don't cancel and the y's don't cancel. So I got to do something to make that happen. So Patrick, what did you say?
Bottom by -2.
He says we're going to multiply the bottom by -2. Not the only option for sure, but does that create a situation where when I add, I lose a variable, I eliminate a variable? Remember this from like ages ago? All right, so what am I left with when I add? I got 5y equals 20. When you do this, guys, remember that when you multiply by -2, it's all the way across. Don't forget, you're multiplying everything by -2. All right, so y is 4. So I'm going to get one ordered pair, and the y is 4. How do I get my x? Just like I did before, I'm going to plug it in. It doesn't really matter where I plug it in, anywhere you want. I'll just put it in this one. So 2x plus 4 equals 10. If I put 4 in right here. So 2x equals 6, and it looks like x is 3. If it's a quiz or something and I want to check my answer, go to the other equation and put in 3 and 4 and make sure it comes out to be -5. All right, would you try B on your own? Same exact kind of problem. And the directions say eliminate. So try problem B. Don't look up here. I'm going to do it up here. Don't look up here. Do it on your own. Are you going to have to multiply both rows by something? Yeah. So take care of business, do what you need to do. You guys wonder why I always have bags under my eyes. It's because I have to stay up late at night making up problems like this that have nice, neat answers. Because if we just randomly threw problems up here, the answers would be things like 11/19, comma, 27/31 or something, right? It'd be really weird. Anybody have a question about that? Okay, no question about that. Everybody got -2, 3. Did anybody, I eliminated the y's. Did anybody eliminate the x's? And your answer is the same, right? It's not going to matter what you choose to eliminate. Eliminate whatever you need to eliminate. All right, one more. Elimination. All right, so go ahead and eliminate here. I'm not going to do it this time. Do it by yourselves. And tell me what you come up with. what happened last time. What happens this time, Lillian?
Does it equal 0?
Well,
0
this side is 0, and this side is 0. Now, I can't remember the numbers we got before, but we got something that wasn't right. Like 4 equals 12, or something like that. That's not right. When that happens, that means no solution. That means you got parallel things, or things that don't intersect. What does this mean? There's infinitely many solutions, because why? These are the same equation. So if you graph that one and you graph this one, they would be right on top of each other. So they intersect in infinitely many points. These are the same line. They're not parallel lines, these are exactly the same line. They are different versions of the same line. There are infinitely many solutions. So you can either say infinitely many solutions, or you can say they're the same line. What you can't say is all real numbers, because it isn't all real numbers. The solution set, if that's one line, and the other one is right on top of it, this isn't a solution. These aren't solutions. So it's not all real numbers. It's just the points on that line. See the difference? Okay. Perfect. All right, now we got number 3, which is going to be a little bit more of a challenge, it looks like. So let's see if we can fight through. It doesn't tell us how to do it. You can do it however you want. Sir, what do you think?
To keep it from being like fractions, could you divide out a 2 and then multiply like an x or a y? So like you would get divide out the 2, x plus y equals 50,
Okay.
and then multiply x and then get x squared plus x, or like negative x, get negative x squared plus negative xy equals 50x, cancel out the xy and then solve at that point.
Okay, we can do that. I don't know that that's saving us anything, but we
Okay,
can
because I just don't want to
absolutely
do
do.
fractions.
No, oh no, you don't need fractions, because sir, can't we just get x by itself, let's say, and plug that in here, and then there's no fractions. Now, if you got this x by itself, then you would have fractions. Yeah, but, so we can do what you said, or we can just do this. So does everybody see what Sir did? He divided that top equation by 2. You don't have to do that, but it's going to keep your number smaller. And then we got x by itself here in this new equation. And now I'm going to substitute it in. So my equation is going to be 50 minus y times y equals 300. You may have had a different idea, but you understand what he's doing? I think it's good. I think it's fine. Okay, so we've got 50y minus y squared equals 300. Donovan, what do you think we ought to do with this now? This is where we are after we substituted and distributed. What do you think we ought to do now?
Take a light.
Well, if I took a y out, I'd be right back to this step right here. And remember, that doesn't do me any good unless that's a 0. And it's not. So I think keeping it this way is best. What kind of equation is this, Donovan? Starts with a Q. Quadratic. And what do we always do with our quadratic equations? Set them equal to 0, and then either factor them or use the quadratic formula. Or you could complete the square if you wanted to too, but regardless, we want to get a set equal to 0. So I'm going to move everything over. So I have y squared minus 50y plus 300. Quit scrolling on your watch. All right, what do you think
Did
then?
you have divided by 50 right there?
I could have, but then it would have put this over 50. Remember, I gotta divide everything by 50. So that would have left me with a fraction. I'm with Sir, I don't want fractions. Well, we can sit here and stare at each other, or we can do what? Lillian?
Would you use the quadratic formula?
I think so. I don't see a way to factor it. I'm not saying it doesn't factor. I'm just saying I don't see it. So I'm not going to sit here and stare at you. Let's just do it. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. Check my arithmetic. You have a calculator. I did that in my head. Did I do that right? 2,500 minus 4ac. So that's 50 plus or minus the square root of 1,300. So 50 plus or minus 10 root 13 over 2. Remember, the square root of 100 is 10. So I'm going to pull the 100 out and the 13 has to stay. Now, Ben, I can divide, not by 50, but by 2. So I have y equals 25 plus or minus 5 root 13. As my kids used to say when they stepped in dog poop in the backyard, yucky doo-doo. Guess what you get to do with that number? Plug it in. So you have two answers. The y values are 25 plus 5 root 13 and 25 minus 5 root 13. Does everybody understand that? That's what came out of my quadratic formula. So now I'm going to come back here, right here, to what we had when we substituted. And x is going to be 50 minus 25 plus 5 root 13, or 50 minus 25 minus 5 root 13. Those are going to be my y, or my x values, because x is 50 minus y. Alright, so what's the first one? 50 minus 25 minus 5 root 13. So that x is 25 minus 5 root 13? Is that right? And this one will be 25 plus 5 root 13. Donovan?
Why wouldn't you just solve the y and then put the numbers, like, solve it twice with negatives and then plug it back in? You know what I mean?
No, tell me again.
Like, 25 plus 5
Yeah.
root 13, why wouldn't you just solve that instead of just leaving it?
Oh, you mean type it in on my calculator and get a decimal?
Yeah.
Because I answer exactly whenever possible. So if it said, if the direction said round to the nearest hundredth or something, then you could do that, plug that in, and then take that decimal and put it in. But we're doing it exactly, no round off error. Everybody okay with that? All right, that's probably enough. 7.1 homework will be due on Friday.